Welcome, engineers, to 3.1, Part 3, which is Introduction to Programming. Today what I'm going to do, I'm going to take you through some of the basics of programming and how do we organize ourselves, how do you test bits of code, how do you actually write code. So I'm going to take you through some very simple steps in writing code so you can kind of see some common techniques that we as coders use in building a program. So let's get started. This PLTW, it breaks down programming into like 3 different types of behaviors. And this is going to make more sense to you as we go on, but right now this probably won't make sense to you. So there's complex behaviors, simple behaviors, and then basic behaviors. I'll give you an example. A few years ago in engineering class of ours, we built a can crusher. A complex behavior would be crush the can. But what else is going on is when there's no can in the can crusher, there's a green light that pops on, and there's laser etched on a piece of plastic that says standby. And then while you were crushing a can, there was a yellow light that lit up that said crushing in progress. And if there was ever a jam, like you'd crush the can, sometimes it wouldn't fall out of the crush chamber, a red light would light up and says jammed. So that's pretty complex. You know, like you have to sense whether or not a can is there. You have to actually only let one can in at a time. So if you push down 5 cans, you got to only let one in. So this is a really complicated thing. So the complex behavior is crushing all these cans. A simple behavior would be something like, once there's a can inside there, crush the can. But in order to crush the can, you had to, number one, run the motor forward for 30 seconds to make sure that it crushes the can, and then run the motor backwards 30 seconds to let the can fall out. So a basic behavior is run the crushing ram forward. A basic behavior, run the crushing arm backwards. A simple behavior you could call, so like going forward and going backwards together, that's kind of a simple task, like crush the can. And then the complicated task is, okay, then check, is it jammed? Is there another can there? So like inside of your program, there are simple things like run the motor forward. But there are also really complicated things like if there's a jam, then don't run this forward, or if there's another can, then run the cycle again. So the 3 different types of tasks, we'll get to those. Don't worry about them right now. You'll know when you get to something that you're trying to code that what's going on. Next thing, pseudocode. Let me talk to you about that. So I'm going to boot up Robot C, and maybe you've noticed already that there are 2 Robot Cs. Be very careful. Always choose Robot C for Vex. Never choose the graphical one. So we're going to go there first. Boot that up. Maybe. One of the things that you're going to want to do, you're going to open up a sample program. Whenever you make a new program, open up the sample, scroll down to PLTW, go to the PLTW template, open that, and that's going to kind of give you a template for building your code here. A couple of other things you want to always check. You want to always make sure that you are running a Vex 2.0 Cortex. So if it's a Vex IQ that is bad, you can go down here and you can click the Vex 2.0 Cortex. And you also want to make sure that this natural language is selected. And I'll show you why that's important right here. So you saw me before in my previous video how I made a robot go. I started the motor, stopped the motor. And I was trying to click and drag. It's right here under natural language. If you click this drop down under natural language and then you do movement, start motor, I can click and drag my code right down. Oh, look at start motor. And if you remember, I think I called it like hair motor. I can just, and then you type in the speed. So I remember I started mine at, I think it was 20. So you can just click and drag and then stop my motor. I can click and drag this down. So you can't do that if you go to window or robot platform type, and if it's on natural language 2.0, watch this. Then I click natural language, my movement is no longer there. Like, oh, motor commands. Stop all motors, set motor, reset, move. The common functions that we're going to use with our test bed and our robots from here on out, they're no longer kind of there. They might be, but they're not as easily seen. So make sure that when you're in the natural language PLTW, and that's going to make sure that you have all the different things that we're going to be using in POE for your robots. And feel free to explore, so pseudocode. What pseudocode is, it's a way for us to tell the user what's going on. So right here, we always denote pseudocode two ways. You can do a double / and it will turn everything behind it green. And if it turns green, that means that the computer is not reading that as executable code. The other way to do it, so you can do it line by line. So you could, and you saw me do that in my practice code, where I would always tab out here, and I would do // and I would insert my code. Or if you want to do a whole block of stuff, you do / star, and you'll see up here, / star, it's like a left parentheses. Everything behind it is going to be green until you turn it off. And then you do star /. Watch this. If I delete this, everything's going to go green. See that? See how that went green right there? Because it's just everything behind that is now a comment. So star / there. This is actually really helpful in diagnosing your code to see if it's correct or incorrect, and I'll show you that in a little bit. So suffice to say, your comments are, you do 2 / to do a single line, or you do a / star to do a block of stuff. So here's what we're going to do. I'm going to make a code for an example. You want a warning light to come on before a fan starts for 3 seconds. So a light comes on for 3 seconds, then the fan turns on until a button is pressed. A different light comes on for 3 seconds before the program stops. So here's what we need to build. We're going to make a light come on for 3 seconds. We're going to turn a fan on until a button is pressed. So a fan's going to run continually until you push the button to stop it. And then after we stop it, then we're going to turn on a light for 3 seconds. So let me show you how I would pseudocode that. I'm going to jump over here. My first code is going to be turn on a warning LED. And I think at this point what I'm going to do is I'm going to name my parts. So I'm going to go to robot. And so you have to make sure that you do this. You have to set up your motors and your sensors. So what I'm going to do is my first port, I'm going to put a fan motor. So I'm going to plug in a motor into port number 1. I'm not going to reverse it. I can reverse it here if I want to. I'm going to put a push button. That's a digital sensor. So down here, a touch right here. So I'll type it, I'll just call it button. Maybe I'll call it push button, push button. And then I'm also going to put in an LED. So I need to have 2 LEDs. I believe that they are, where do I put LEDs? Oh, there it is, LEDs. They're a digital. So if you never know do I have a digital or is it an analog? So you can just click here to say, oh, this is going to be a digital. So I think I'm going to plug an LED into digital number 3. So I'll make this a Vex LED. We'll call this warning LED. And then we'll put another LED and we'll call it finish LED. Because remember, the code called for us to turn on an LED when it's done. So I'm going to name them something appropriate. Warning LED, finish LED. I don't think that you can have spaces in here. So I'm going to name my things. So here I go. Oh, I think I need a motor. Yeah, I do. So I've got my fan motor, I've got my finish, my warning, and my push button inside of here. So here's my pseudocode. So here I am. I'm just entering in the pseudocode. I realized as I was recording, like, man, this takes a long time. But what I'm doing, I'm just basically writing in sentences what I want to happen. So we want to turn on the warning LED first of all. Then we want to wait for 3 seconds, then turn the LED off, then turn on the fan motor, because we turn the LED off at the same time we turn the fan motor on. And then you want to wait until you push the push button. When the button is pushed, then we turn the fan motor off. When we turn the fan motor off, we then simultaneously turn on the finish LED. Even though they come one after the other, as far as the computer is concerned, they happened almost simultaneously. So I'm just entering in my name and everything, and I go back to the my pseudo, and I just copy this. I copy this in, and I put it actually into the pseudocode because I think it fits better there, and then I give it a different task name. Let's go through, I think I've done a lot of this right now, so I'm going to go through actually showing you how to do that. Now, number one, you're going to use a lot of these functions enough times that you're going to be able to just turn, I know how to turn on an LED, I can just type it. But I think if you go over here underneath the natural language, let's see here, special, look at this. Turn LED off, turn LED on. So here's our first bit of code. Turn LED on. Oh, shoot. I think this is going to be tricky. Turn on LED, and then you have to reference what are you turning on. So you can call it by name, and I called mine, I look up here, it was called warning LED. So I can just type in warning LED. Or you can type in, it was digital number 13. So you could, if you wanted to, and this is kind of tricky, DGTL 13. This will work also. You can call it by what it's plugged into, digital 13, or you can call it by name. I would suggest you call it by name. It's easier when you do that. So I'm going to wait for 3 seconds. So I can go over here to wait, wait time. Ooh, you can wait in milliseconds too. So I'm going to wait. Like, this is tricky. Wait time. And I wanted to wait for 3 seconds, so I'm just going to insert 3 here. Tab that back out. Turn the warning LED off. So I can go back to my, I think it was special. Yeah. Turn LED off. Oops. Golly. And it was the warning LED. I'll tab all these out. And turn on the fan motor. So you could remember that we did start motor and then that, or it's over here in movement, start motor. So I can go here, start motor. It was called and I can scroll up if I forget. It was called fan motor. And you'll frequently have that. You'll start naming lots of stuff. And let's do it full blast. 120. Wait until the push button is pressed. So it's going to start this motor, and then there's an until function. See these until? I wish I could increase the font over here. I tried, and I couldn't. I think I have to go into the computer to do that, not the program. So we can do until button press. Look at until bump, until button press, until dark, until encoder counts, until the light hits a certain threshold, until the potentiometer is greater than, until potentiometer is less than, until release. That's when you let go. Until rotations, until sonar, until touch. So we have all these cool until. We're going to do until bump switch. So we're going to do until the bump switch is pushed. Now, the bump switch that we want to do, I think I named it push button. Yep, push button up here. Delay time. Now, this is really important. Because when you push a button, because of static electricity, when the connections get really, really close, it could trigger it. When you push a button, they call it bouncing. there could be some what's called bounce. So when you get close to closing the switch, the static electricity the computer thinks that it touches. So you could, when you're pushing a button, you actually could be pushing it like 10 times, even though you're pushing it once, because that static electricity triggers it. So you want to put in a bounce time. You want to delay this like 50 milliseconds, 0.05. When you delay, that means, nobody's going to push a button more than once in 50 milliseconds. So human beings, or when you push a button, it's going to be over the course of a second. So put in a little delay time there. I think that your program calls you to do it a different way too. I think it was on page 31 here. Yeah, so you can do this. They put until bump, and then they named it bumper, and then they put a wait function afterwards. So I could do it this way, all in one, push button, 0.05, or what I could do is then put a wait function in there as well. So I could go wait 0.05, and this will do the exact same thing. Okay, so next thing I want to do, wait until the push button is pressed and then turn the motor off. Okay, so after the code, as you go through here, the code's going to go through and it's going to wait right here. The code is going to stop until this happens. So it turns this on and then it immediately goes to this next one and it forces the code to wait for 3 seconds. And then it goes bang, bang. This is where they talk about processor speed inside of a computer. It will go from this one to this one in like picoseconds, really, really quickly. And then it stops right here. And then we wait, and then we're going to turn our motor off. So then we're going to go back, I think it was motion, stop motor. And we called it fan motor. And you have to make sure it's capitalized. See how I didn't? It was lowercase stop motor fan. You don't have to put a speed because stop just means stop. Okay, we turned our motor off and then turn the fan motor off. Okay, so this actually goes up one. Turn the fan motor off. We did that right here. Turn on the finish LED. So turn on, we'll do our turn LED on. And it was called finish LED, I believe. I go up here. Yep, finish LED. Turn it on for 3 seconds. Wait for 3 seconds. I can just type it in. Wait 3. And then we'll turn it off. So then you can just turn LED off. So I can just type it out too. Finish LED. Sometimes that's faster if you just know what the code is you're going to use. So now I'm going to make this look neat. Now, and then we're done. I think that's it. For 3 seconds and then the program stops. The program's going to end. If you come to me and you say, Mr. Hare, my code doesn't work, the first thing I'm going to look for is if you don't have comments, I'm not even going to help. I'm not even going to look at your code because this is very basic code right here. These, very shortly, we're going to get into some really complicated stuff. If then else statements, while loops, nested while loops, functions, and your code can be insane. It can be so complicated that I can't follow it. I want you to get into the habit of putting in your comments. If there are no comments, number one, I won't help you. I will make you put comments in before I even look at your code. Number two, when you turn your code in for homework, if there's no comments, it's not counted. So it's super. I can't stress to you enough how important comments are. And you might say to yourself, this is so dumb because it takes more time to actually write these out than it does to make the code. And you're right. You're right now. But when your code gets really complicated and then you go home for a weekend and then you come back to it, or there's blinds in my room that I don't come back to that code for years, it's so important, kids. You talk to any coder that you know and you ask them, how important are comments in the code? And they'll tell you that they're probably the most important thing. So please, 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 I need you to do comments. I'm not going to look at your code if it doesn't have comments, and I'm not going to accept your code as homework unless there are comments. So there you have it. That's some of the basic tools. Oh yeah, I wanted to show you this. There's one other thing. This is cool. What if your motor wasn't working? So what if something isn't working? And so you're wondering, is it the motor or is it the code? There's a way to modify your code. Watch this. If you're like, I just want to see if the motor's working, you can turn off this code. Look, see how I turned off the code by commenting it? You can comment the code out. See that? I can turn bits of code off. So now it's just when I run this code, the LED should turn on off immediately and then start the motor and then it ends. So I probably want to wait to make sure my motor's working. So there you go. So if you ran this code right now, this code would go so quickly. It would turn this on for a picosecond. It would turn it off the next picosecond. It would start the motor for a picosecond, and then it would end the program. So this wouldn't do anything because your computer goes through it so quickly. You want to make sure that you wait. So I just want to make sure my motor's working. So you run this code, and now you can diagnose to see if your motor's working. And that way I didn't have to delete code, so I can come back and I can turn my code on without deleting things. Or if you're baller, you can delete a lot of code, right? Remember the little trick? /*, and then you want to */ because you want to make sure your brace isn't commented out. So you can turn off a whole section of code using the comments, and that's a really handy tool that I think that you would be very well served using in the future. All right, kids, thanks for hanging with me. I appreciate your time. Good luck with your coding.